Hey DJ Dialects, I'm here to help you with your physics problem. The write-up, I promise, it was a little too complicated to put into words, so I'm making a video instead. The reason this whole crazy physics glitching is happening is it looks like you're controlling your spinner with an animation. And the animation, what it does is it edits the transform values of your spinner directly. So it's modifying the rotation values of your spinner directly, and that's causing it to teleport inside of your player here. And then the player gets teleported when it sees there's something inside of it. It tries to right itself, and on righting itself, it pops right out, and then the spinner just teleports right back inside of it, and it kind of just seems to carry along the player. It's kind of just stuck in there until it drops out eventually, or it glitches itself free. The reason we can't use an animator to control our spinner is because if we want something to interact physically in the world, it has to itself be a physics object. So it can't just be teleporting its rotation around. It has to be attached with a joint and have a force acting on it that's causing torque, and that's causing it to spin. And then that will apply, if it knocks into something, it'll apply its torque force to everything it hits. So in order to make a spinner without an animation, we're going to use a hinge joint. Here I have a sample scene set up. It's just a plane with some walls around it. We're going to create a spinner, so we'll create a quick cylinder. We'll zero it out. Oop. And then we'll create the spinner's arm. Cube. Take the cube, move it to the side, and we'll scale it up. Scale is 9 on the z-axis. We'll move it over for clarity. The cylinder, we're going to add a rigid body. We're going to say it's a kinematic rigid body. We don't want it to respond to any forces done on it. We're also going to freeze its rotation and its position. We'll leave its position the way it is. We'll take our arm. It's also going to be a rigid body. It is. Then we're going to add a hinge joint to it. Now, a hinge joint is a joint where you have one rigid body usually rotating around another rigid body in your scene. Here, the first value they want, the connected rigid body, they want the rigid body that you're going to be rotating around. So we'll take a cylinder, we'll call it our spindle. I'm sure that's spelled correctly. And this cube we'll rename to our arm. So we'll take our spindle, we want to be connected to our spindle. Now the anchor property is basically specifying what position in the arm's local space do you want to have rotate around. So basically specifying our axis of rotation for our arm. You can sort of see it in here, but see this little orange arrow here? That's specifying the our anchor and our axis. Right now it's pointing to the positive x direction. We'll change that later. So we want our arm to be rotating around in local space around this its left side here. So we'll take our anchor, get rid of the y. Oh, we can leave the y, and then bring the z back, z to negative 0.5. You'll see there. Yeah, we'll get rid of the 0.5. And you'll see now that orange arrow, I don't know why they made it so tiny. Is there a way to make it bigger? There's not. Right there, that's the axis it's going to be rotating around. Now you notice it's pointing to the right, which means it'll be rotating across the x-axis. That's not what we want. We want it to be rotating around the y-axis, the vertical axis. So we'll zero out the 0 for x, put 1 in y, and now our arrow is pointing up. So now that arrow will be, or now our object will be rotating around that orange arrow. The connected anchor is the property, what position in local space on our connected body, so our spindle, should we be rotating around. And we want to not have it auto-configure. Auto-configure does a little bit of stuff that we don't need to right now, but for now we'll say we want it to be 0, 0. Now, again, this is... Can I make this wireframe? Okay, good. So now we got 2 arrows here. This orange arrow here, I wish they changed the colors, but they didn't. This will be the axis in local space for our arm that it's going to be rotating around. And this arrow here is the axis in local space of the spindle that the arm's going to spin around. And when we hit play, what Unity is going to do is going to join these 2 arrows so they overlap. It'll be like this. It'll squash them together, and then it'll start rotating them. Well, it won't start rotating until we also specify that we want to use a motor on this hinge joint. And the motor, we just say, hey, how fast do you want it to spin? We'll say 100 angular velocity, and the force, we can give it a particularly large force just so if something gets in its way, it won't hinder the motor at all. It'll just plow right through it. Let's go back to textured, and if we hit play, let's see what happens. We got our arm spinning around our spindle. Looks pretty good. And then I added some spheres here, bring them in, arm comes. Now you notice when the arm hits these spheres, it kind of wobbles around and everything, doesn't act very sturdy. We can fix that by going to our arm and say freeze. We'll freeze the rotation on the X and Z so it doesn't twist at all. But it will rotate around the Y. That's what we want it to do. We'll also freeze position in the Y axis so it doesn't move up and down. It won't just go over the spheres. It'll knock right through them. So I'll try it again. Get the spheres going. Spindle spinning around. Everything's going great. So that's how we got a spindle. You can mess around with the axes for the hinge joint. Auto configure connected anchor just basically makes it so if you specify an axis in the arm's local space, it'll automatically update it so the same point, it'll transform that point into the local axis or the local space of the spindle. It gets kind of weird. Like you, let's say we wanted to move we wanted, instead of spinning around the outside here, this outer edge of our arm, we can specify the center 0, 0, 0, and now we're spinning around the middle. We've got a middle spinning arm. If you wanted to get fancy and have you wanted to have the arm, let's get these spheres out of the way. You wanted to have the arm spin on the outside of the spindle instead of being, you can see it kind of is clipping through it. If you want it to spin through the outside, you kind of have to do some crazy math, because if we move the connected anchor axis, because remember it's gonna bring those 2 arrows together, so it's gonna squash them together like that. So if we want this arrow to also be on the outside, we can hit auto configure, and then it'll convert this point in the local space of the arm to the point in local space of the spindle. But now if we run our scene, you'll see it's now spinning around that axis. It's not spinning around the spindle. So we kind of have to keep the connected anchor. We need that axis in the middle, but then what we want to do is bring this axis to that one. So if we slide it this way, we can get close. The actual math has to deal with the scale of your arm. So if our scale is 9 divided by 2, I think, and then we add 1. Oh wait, 1 divided by 9 divided by 2 plus 0.5, 0.5555555. Oh well, that's what we got here. 5. You see, it moves practically on top of it. And now, if we run, you can see our arm is now rotating around the outside of our spindle. But it's usually good, you can just disable the mesh renderer on that. So we just disable the mesh renderer on our spindle if you wanted it to not be clipping through, and just change the arm model to also include the spindle, and then just bring it so they clip through each other. They don't have to know. Players don't have to know. So yeah, one way to get a spindle working. If you've got a player, let's add a quick player. So I got a player. We got the force that we're going to move at. And then in the fixed update, we're going to apply our forces. We'll make it there. We'll say rigidbody and new vector 3. So I add force to it. I choose force mode acceleration just to get it going, and I choose axis raw just so I don't have to deal with the dampening and springiness of the regular axes. Yeah, so that's basic code for a physics player. If we drop let's create a capsule for a player. Capsule. We'll move them over here. Our player also has a rigid body. We're going to freeze its rotation in the X, I guess Y and Z, so it can't fall over. And then we'll apply our physics player class. Move force. We'll say a move with the force of 15. Hit play. Oh, why doesn't he move it? Oh, hey, forgot to multiply by the move force. So is that? See our guy, we can move him, run into the thing. I can push against the arm, but because it's got so much force powering it, I can't really do anything to stop it. And everything works fine. If we can set it up similar to how it's set up in your game. If I drag the player out, take our plane, and oops, wrong way, squeeze it down. And now we can try and cross. If we somehow get caught, we can get pushed off into the netherworld. Alright, so we got a spinning arm. Now for the moving platforms, I'm assuming you've got an animator for the platforms as well. And we can't use animations for physics objects, and moving platforms are kind of, they're definitely physical, but they're kind of hard to do with physics. Let's create a new scene. First, we'll tackle creating a moving platform without using animations. So we'll create our platforms. We'll just create a cube. We'll shrink it down flat. Give it a grid texture. We'll also reset its transform. Oh, well, I got rid of our shrinking. Shrink it back down. Okay, got a platform. And then we'll create our C# script. Unfortunately, it has to be done with the script. Moving platform. Get in here. So for our platform, we're gonna have it where we'll have two transforms in our scene. One will be called start. I don't know why that's I don't know why the mouse is over here and it's drawing over there. Start, and then we'll have it start and end. And then we'll just have the platform just move from the start. It'll go to the end, and then it'll ping pong back and forth. So we gotta start. It'll be going to the end, and then back, and then back. You notice, hey, if you swap this around, that looks a little familiar. We're gonna be using a cosine wave to control our platform's position through time. Our cosine here, we've got cosine of the total time elapsed in our game times 2 pi. Will give us a curve like this. We want 0 to be when we're at the start. I don't know why the pen's not working. Start, and then 1 we want it to be at end. So we have to do some transformations to this curve in order to get it to only go between, let's say, 0 and 1. So first thing we're going to do is, we can't start at end, we want to start at start. So we're going to just take the negative cosine of that, and now it's flopped around. And then we want to get it so it's only between 0 and 1 instead of -1 and 1. So we're going to squash the amplitude of it by multiplying it by 0.5 and then translating it up by adding 0.5 to it. So we've got this now. Nice little curve. Going to start, going to end, back to start. So now, in order to get our platform to shuffle between, or control the rate at which our platform moves between start and end, we're going to also then divide this inside part by a constant we control. I'm going to call it move time. So like if our move time's 5, that means that it should take 5 seconds in order for the platform to move from start to end, back to start. So if we add that in there, we just got the -1/2 cosine of the time elapsed in our game divided by our travel time times 2 pi plus 0.5. And we get a nice wave that will control the position of our platform. Now I know this sounds a lot like using an animation if we're just going to set our platform's position in time based off of a curve. But the reason we're doing it this way is we can use the function rigidbody MovePosition, and that'll allow it to using rigid body move position, it moves the rigid body through the world, and it applies physics forces on anything it happens to contact along the way. So it's not just teleporting from position to position. It is moving through the world, through the physics world, and acting accordingly. So for our moving platform, we're going to need public transform start, our start position, and end position, our travel time, alright, and then all we need is in our fixed update, we're going to say, we'll create a temporary vector 3. Our current position in the world should be defined as we're going to flip between our start position and our end position. So we're going to lit between them. The constant we're going to use between to signify how far between the two we should be, we're going to use our fancy cosine function. So math f cosine, and we're going to do time dot time. So the total time elapsed in the game divided by our travel time times 2 pi. And then we're going to multiply that by negative 0.5, and then add 0.5. Yep. And then all we have to do is say, hey, rigid body, move to the position, current position. So alert between our start and our end using this constant, and then move to that position. So if we save it, go back to our scene, we'll create some empty game objects. This one will be start, duplicate it, this will be end. We can give them a fancy tag so we can see them in the world. Start, end will be red. So we'll take our start, we'll move it over here. We'll take our end, we'll move it over here. Take our camera, align it with our view. Probably add a light. Not a point light. And we'll move it out of the way. Okay, so take our cube, we'll call it moving platform. Add a moving platform script. Where's the start? It's going to start from there. Where's the end? It's ending there. Travel time, we'll say 5 seconds to make a round trip. Hit play. Oh gosh, I already got an error. Oh, forgot to add a rigid body. Whew. Rigid body to our moving platform. It needs a rigid body. It also has to be not using gravity. And again, is kinematic. And I guess we'll also freeze its rotation so the player can't mess with it. Okay. Onward. Oop. Got a little bug. But it certainly is hopping back and forth between them. Let's see, back to our script. Where did I screw up? Oh, I got the decimal point. Hot dog. Alright, look at that platform move. We'll look in our scene as well. So it's moving between start and end. It's taken 5 seconds to get there. If we drop this down to 10, You can see it moves even slower. It kind of jumps around just because of the way we're lerping between our positions based off of the total travel time, so things like that happen. It's not the best solution, but it is an easy solution. If we were to take our end, let's say move it over here, you can see updates real time, move in between there, real slow. We can bring them together. We can drop it down. Neat, that's a good moving platform. So now we can duplicate our platform. We'll take away the moving aspect of it. And then we'll add our player capsule. It's a really big capsule. So make a player, it's a rigid body with frozen rotations, it uses gravity, and we'll add our physics player script. Oh, forgot to give it some force, 15. Alright, so we're here, just waiting to get on our platform, hop on, it moves us along. We're kind of sliding around on it. It's just the way physics goes. That platform's a little slippery, so it stops. We're still going. We'll slide forward. If you want, you can create a physics material. Create a platform material. You can give it a lot of friction. And then take a thing, apply it to the collider. So now if we were to jump on it, we don't slide around as much, but it's also harder to move around on top of. You kind of can't feel it, but whoa. It's pretty sticky on that, so it just needs some fine tuning. So yeah, there you go, moving platforms and spinners using physics. As you can see, it'd kind of be hard to get all of that in a Reddit post, so hope this helps. Let me know if you have any more questions. Thanks. Bye.